Have you ever wondered if we could take our best medicines and somehow make them even better? Today, we're going to dive into a natural compound that might just do that, and in the process, completely change how we think about fighting infections.
I mean, seriously, think about it. In a world where we're hearing more and more about antibiotic resistance, what if the answer wasn't just finding brand new drugs, but making the ones we already have work way better? It's a huge question, and believe it or not, the answer might be coming from a place you never expect.
You heard that right. Not from some futuristic high-tech lab, but from a natural compound that's all around us. We're going to explore how a simple substance from things like yeast and mushrooms could become the ultimate sidekick for our most important antibiotics.
Now, to really get why this is such a big deal, we first have to understand the problem we're up against. Our best drugs are facing some really tough challenges, especially when we're talking about the most serious, life-threatening infections.
And a perfect example of this is sepsis. Now, this isn't just an infection. It's when your body's own immune system basically goes into overdrive trying to fight an infection, and that response itself can cause massive damage and organ failure. And here's the scary part. Even with our very best antibiotics, the death rate from septic shock is still shockingly high. That tells us we need more than just a powerful drug. We need a whole new strategy.
So what if that strategy wasn't about hitting the bacteria harder, but about training our own bodies to be better fighters? Well, this is where the story gets really cool. Let's meet our immune system's new personal trainer.
It's called beta-glucan. So, what is this stuff? Well, chemically, it's just a long chain of glucose. Sugar molecules. But it's the way they're linked together that's the secret sauce. You find it in the cell walls of things like baker's yeast, mushrooms, even oats. And its main job in this context isn't to be food, but to act as an immunomodulator, which is just a fancy way of saying it trains and fine-tunes our immune response.
And this is absolutely crucial to understand. Beta-glucan is not an antibiotic. It doesn't attack bacteria directly at all. Instead, it puts our body's first responder immune cells through a kind of boot camp, getting them warmed up and ready for a real fight. Scientists have a great name for this: trained immunity. So how does this training session work? It's actually pretty brilliant. First, your immune cells spot the beta-glucan and recognize its structure, thinking, hey, this looks like a fungus, I should probably pay attention. This doesn't cause a full-blown attack, but it does put your key defender cells on high alert, a state called priming. And then, when a real bad guy, like a bacteria, actually shows up, these already primed cells launch a response that's way faster and much, much stronger than it would have been otherwise.
Okay, that all sounds great in theory, right? But does it actually work in practice? Let's take a look at some really compelling animal studies that put this whole immune training idea to the test.
All right, our first piece of evidence comes from a study way back in 1998 that was looking at a really common and dangerous bacteria, staph. So here's the setup. In this experiment, researchers used a beta-glucan that came from yeast, and they gave it to guinea pigs. Then they exposed those guinea pigs to staph bacteria. And the results? Well, they were pretty jaw-dropping. The animals that got the beta-glucan were way less likely to get infections. But the scale of the effect is what's really wild.
I mean, just let that sink in for a second. The immune systems of the guinea pigs that got the beta-glucan were so fired up, so ready to go, that it took 60 times more bacteria just to get an infection started compared to the untreated group. 60 times! That's an incredible demonstration of just how powerful this immune training can be. Okay, so it works in guinea pigs against staph. But what about other animals? And can we measure the immune boost in other ways? Let's jump to a different study, this time with piglets, which are actually a pretty good model for human biology in a lot of ways.
So in this one, piglets were fed a diet with yeast-derived beta-glucan mixed in. And what this chart shows is a few really cool things happened. First, their immune cells got better at phagocytosis. That's literally the process of eating invaders. They also produced more of an important immune signal called IL-2. And get this, after a simulated infection, they had lower levels of the stress hormone cortisol. So you get a stronger immune system and a lower stress response. That's a huge win-win.
So the evidence is really starting to pile up, right? A stronger, less stressed immune system seems like a no-brainer. But, biology is never quite that simple, and as researchers kept digging, they found a really surprising twist.
So check this out. In a 2011 sepsis study using mice, a pretty stunning gender difference popped up. When they gave the yeast-derived beta-glucan after the mice already had sepsis, the male mice got a survival benefit, but it only lasted for about a day. The female mice, on the other hand, They had a huge long-term survival boost that lasted for 10 days, and they had fewer bacteria hanging around in their livers. This is a huge clue that things like hormones could play a really big role in how well this immune training actually works.
So we've got this incredible immune trainer that shows a ton of promise, but also has some interesting nuances. Now, let's circle all the way back to our original problem, making our antibiotics work better. And let's be super clear here. The goal has never been to replace antibiotics. They're amazing, life-saving drugs. The idea is to use beta-glucan as an adjuvant, which is just the scientific term for a helper. It's designed to fight alongside our traditional medicines, creating a powerful 1-2 punch against infection.
So how exactly does it help? Well, like we've seen, it gets our own immune defenses primed and ready for action. This lets our body do a much better job of cleaning up all the bacteria that the antibiotics have already weakened. Plus, it can help dial down that massive damaging inflammation we see in conditions like sepsis. When you put it all together, you get a synergistic effect.
And hey, don't just take my word for it. The researchers from that original guinea pig study back in '98 said it themselves. The combination of beta-glucan and antibiotics gave them enhanced protection that was way better than just using antibiotics alone. In other words, 1 + 1 was equaling way more than 2.
This all paints a really, really exciting picture, right? Beta-glucan looks like this powerful, natural tool for boosting our own defenses. So, what's the next step? Where do we go from here?
The big takeaway for today is pretty clear. We've got a ton of research, mostly in animal models for now, showing that beta-glucans, especially those from yeast, can literally train our immune system, making our bodies a much better partner in the fight against dangerous infections.
So does this mean we're on the verge of tossing out our antibiotics and just relying on our own super-trained immune systems? No way, absolutely not. But it does point to a massive shift in how we might approach these problems. The future of fighting serious infections probably isn't about finding one single silver bullet. It's about building a smarter strategy, using our targeted antibiotics to weaken the enemy, while at the same time using something like beta-glucan to train our own internal army to go in and deliver the final blow. It's a powerful new partnership, and it could be a game changer. Thanks for joining me.